Hello everyone, welcome back to the next part of our World One Grasshopper tutorial series. In the previous part, we finished setting up the rough setting out plans for our tower for all the 3 blocks. This is where we ended up with. And in this part, what we're going to do is we're going to focus on the top level, which is this blob right here, because using this component to create the arc for the lower floors, it created an issue for our top floor. Because if we look at a reference photo like this one, do you want to keep animating? Okay, I don't have it. So this one, you can see that it's not a blob per se, but it actually takes part of the curve from this second this part right here. So it takes about somewhere like this. If I were to draw this one over there, it will somewhat end up like this. So it's not going to be as round as this one. So what we're going to do is I'm going to isolate the last part, and then I'm going to modify it in such a way that it matches roughly to what we want. So let's get started with that. So the end result what we got from last time was the arc, which is highlighted in green. What we can do, we can actually just simplify it. It doesn't really matter if you simplify it or not simplify it, but it just looks cleaner and more understandable. So we want to have the last branch, which is branch number 2, which has one element in it. So one nice way to isolate a branch is we can actually use a split tree. And if you haven't watched my previous tutorial explaining about the split tree component, I'm going to explain briefly again what it does. D is input for the tree you want to modify, and M is a mask. It's always flattened, so don't bother changing that. What it takes is, what I usually use it in a way is I will input a path in it, and what it will do is it will sort of split that path to a positive and a negative. It's very similar to split index or split list actually, where you have to provide an index, which is a number. In the mask is actually a path, even though it accepts text strings as input. What I usually do in this case, I will input the path. And how do we get that path? Well, since we've let's put that in. Since we've simplified the tree structure, so the path can be as simple as just typing in 2, and it'll work. And you can see if I do geometry out from, let's say, the positive end, which is going to be our last circle, because that's where it will split to the positive side. And you can see that we selected that part. But what if we want this to be more dynamic? We don't want to type this in. Let's say you made an error and you put in a space or something else happens, or something like that, which can happen. So what we want to do is we want to make the computer or the Grasshopper select exactly the last one based on our logic. And one way we can do that is we use a tree statistics in order to extract all the path, which will be the P. I'm going to connect this here so you can see. Don't want to connect that one. And well, the one that we want is actually the last item. So what we can do is do list item from the path. We're gonna reverse the list, and then we have the last item. In this way, our Grasshopper will always select the last item and sort of like extract that out. So now that we have it extracted, what we want to do is, since we know the curvature is actually based on the floor that's below it, it's that curve. So what I would intend to do is I want to copy this curve. I want to move it here so that it comes here, and then I want to mirror it on this plane so that it will go like that. And the only thing I need to do now is just shatter it from there, and I can apply a fillet command on that in order to smooth that out. So that's my overall plan for this. And what I want to do now is I need to select actually that last one too. So what I can do is, since this one's always selecting the last part and I want to select one before the last, what I can do is go in here, create another submask, tree mask, sorry, and what I want to have is do a list item. Oh, not this one. A list list length. Actually, I want to select, or actually no, the 3 is the one I want. Let me grab that 3 right there real quick. There we go. Or is there another 3 that I can use here? Well, wait a minute. No, I can actually use it from here. Count. Yeah, I can use the count. The count is the number of path. Yeah, that's it. So what I can do is I'm gonna put this into a number. I'm not sure if I can do a expression, or I can. Okay. Okay, then I can just select it here, but let me just put in a panel to explain what I want to do here. So what I want to do is, I know the last item, the last tree branch, is not the 3rd branch because index sort is 0. It's actually a 2, as you can see here. The index where you got here is a 2, or the tree branch. So what we want is actually the branch that is above this one. So if this were, let's say, a 15, what we would want is a 14. So we can actually put that into here. And since it's a 3, we don't want a 3. What we want to do is x minus not 1, but 2. Because if you do x minus 1, then you're selecting the same one as the last item. And that should give us a 1. Which I just deleted that panel, which is this one. So it's the path number 1. And if you select that, you can see that we've selected the one that we want. Okay, so with that being said, let's move the ones that are okay, which is basically the negative of the first tree split mask. So if I do a negative, so if I put a geometry on the negative, you can see that I selected all the floors except for the top. This one, remember, we put this here in order to just select this one because we know we want that curve. That's the block that's right below the top floor. So let me hide a lot of these actually, like that. Let's just put this into a merge for now. Yeah, let's put that into a merge for now. And now what I want to do is let's select this out. Okay, this is that one, and this one is this one. How can I move? Well, actually, I need to filter out. I can see that I'm already selecting that one, but I don't need that one. I just need this one. So what I'm going to do is do a list. No, this with length, and I want to sort it asynchronized with that. Do I even need this? I don't. So I'll just delete that. So here, might be a good idea to just move it all the way down so that it's sort of like visually understandable, clear for us. And I'm going to select, obviously, the one that is the longest. So I'm going to reverse this list so that I'm always selecting the last one, since I'm sorting this by their numbers, by the length. Okay, with that being said, let's see, what can I do here? Well, I can do a CRV evaluation from this curve. Let's parametrize it and do either the start or the end. Oh wait, what? Oh, expression that is 0 doesn't really do anything. What I want is the number to be 0. Okay, so I have that point right there. And let's see which one we have here, which is that point. What I want is actually either I select this point here and then I select that point there, and then I move it into that point using a 2-point vectors. I actually want that back. There we go. Oh, no, I wanted to visualize. Okay. Wait, what? Okay, there we go. Okay, so with that being said, I'm obviously selecting the wrong one here, so I might have to go in here and modify this to 1 in order to select that point, and this one also the same, which is a 1. So now that I have that selected, I can do a vector 2-point that goes from there, because I want to move it from there to this point, and I'm gonna initiate a move using that vector we just created for the curve that we want, like that. I'm gonna do this right here, order this a bit more neat. I don't know how to order this. Okay, I'll just leave you there. Okay, now that we have this one, what I want to do is I want to mirror this to the other side, and for that I will definitely need, can I use something from here? Okay, these are the only things that we can work with, so that's what we do. That's fine, that's fine. Okay, here's what we're gonna do. We're gonna actually use an endpoint, and then we're gonna create a plane using these points and the middle point that's here. So by that logic, I actually don't need this. I already have the points here, so I only need to find which one is the endpoint. I think it's the E, I think. Let's see. Yes, it is. Because if I put it to the S, it moves the other way, which is the start point. Okay, that's fine. Actually, I do need that back because I knew I need the middle point, that one. Okay, so let's create a plane. Plane constructs. Wait, I need one that has that allows me to select a normal. Where do I create planes? Vector plane. Let's see, which one can we get? Create a plane perpendicular to a vector. Oh, hold on a minute. I don't think I need this at all, because let's go to, oh, that one is now messed up. Okay, doesn't matter. Let's go to this one. This point that we created, how does the plane look like actually on the T? No, what I want to do is actually a vector display. So let's go back to top view. Yeah, yeah, we can just do the one that I had, which was a plane normal, plane perpendicular to normal. Okay, so the point can be here. The perpendicular, the z-axis, can be this one, can be the t vector. There we go. The reason why I want this plane is this will be our mirror plane. So if I want to do here and say mirror, we need a plane, and that's the plane that we will use to mirror our objects. In the end, we don't need this. In the end, this one could have just stayed a curve evaluate. So sorry about that if you had changed that. But if you were watching without doing anything, well, now you know. Anyway, so let's mirror our object. There we go. We can probably hide. Oh no, I do need this. Okay, so now the question is, we need to break that, and that's quite easy. We just do a curve-to-curve intersection. Where is it? Here, here, here. This one. Intersection, curve-to-curve. We will intersect curve with curve. And then I'm gonna shatter both curve. Is there a way for me to shatter both curve at the same time? Or, you know what I can do also? I can also just do shatter one curve and then copy and then mirror it again. That might be easier for us. So if you were to shatter this starting curve, the one that we just copied, it goes into B, so we need the parameter from B, and I'm gonna say, you know what, I'm gonna sort it again, because I don't know which one is the longest. So it seems like index 0 is the longest, but I don't wanna put my chances on betting that it will always be that way. Murphy's law, when things can go wrong, it will go wrong. So I'm just gonna do a sort, explicitly sorted by length, and I'm gonna say I want the longest by reversing my list item. So now that I have that, yeah, let's do this. Let's just copy this again. The curve we want to copy is now this one, using the same mirror line. So that's a bit of lazy. So now what we can do is we're gonna join these two curves together using a curve join. The tree might messed up, so you might want to flatten this just in case. This is one of the very rare situations where a flatten is okay to use, because, well, we're only working with two curves and we know there's not going to be any branches in here. You're not going to be flattening two of these. I mean, if you were, you're designing a different tower, then you probably shouldn't be watching this, I guess. But anyway, so now that we have them joined as a single curve, we can go in here and say we want to fillet the sharp corner of the curve using a parameter, and our parameter can be 1 meter, ranging from 1 meter to, I don't know, 10 meters with a decimal, perhaps, like that. See, that looks a lot better than I think this one, you know. And the good thing about it is if you were to move those back in place, you see that it also fits a lot better along this line. So you can actually, you may want to put this parameter in the beginning, but I'm not sure if we're going to be coming in here and adjusting this at all, to be honest. So I put it this 8, maybe like 7? Yeah. No, wait, no, 8. Okay, let's do the middle point, 7.5. If you want to know exact same radius that they've used here, well, you can copy this image and place it into Rhino, and then you can match it that way, which is totally fine too. Okay, so now that we have that done, let's move this back to, let's set this to 80 so that I can just do this. So if you want, you can just select that, and this one goes in here. And there we have all the curves selected. Oh wait, no, only the arcs. Oh, this is gonna be troublesome. Aha. Okay. It's not something that I would like. Wait, what if I simplify? What does it become? Doesn't really become anything. Well, that's not good, because I still need to combine it with this one. Let's put a merge on this one and see how it goes. Okay, so if you were to be merged with this one, now that we have everything, oh, okay, our tree is totally messed up at the moment. If I were to simplify this, the problem comes from this one, because our tree from that one is a 0, 0, when we want it to be a 3. Oh, no, a 2 actually, because it's the last one. So, can I use a tree structure that's come from here? I should be able to, right? Using maybe a match tree or some sort. Actually, I do think there is a component called match tree. Hey, this one. You can find it on set, tree, and that one, match tree. So what does it do? Match one tree data with another. Simple enough, okay. I hope we can pull this off. Input T is tree to modify, obviously that one, and data tree to match, which will be our guiding tree, I suppose. Can we use that one? Even though, wait, But this is a number. I'm not sure that. Wait, what does the tree even look like from here? Doesn't say. Okay. So if I put it to here, oh, what happens here? Well, it does give us the right number of levels, but not the number. We want this to be a 2. It's supposed to be a 2. Okay, that's not the data to match. Actually, let me copy this and have a look at what this tree actually. Okay, I mean that's what to be expected. It's a less item. The tree structure is like. Oh, hold on a minute. This one, yes, the one we split off, the one where we started with. We can match that back. Hey, there we go. And now, so what I want to do, if I plug the T into this D2, what I want to have, I can just do, yeah, I can do get away the simplify. What I want to see is 0, 1, 2, and then the 2, I want to see, how many items do I have here? 1 item. I don't want to see a 2 there. So let's go. Hey, there we go. Exactly what we wanted and exactly what we expect. Now that's a good data. Okay, with this, we've successfully modified our setting out plans exactly the way we want it. I'm not sure if we should join these curves together. Probably not, but we'll see. Okay, with this, you can actually do a explode, or maybe not an explode. You can do a let's say curve command in order to prepare it to for the setting out. So we can just call this main setting out curves. Main setting out outline. That's what we can call it. Yeah, like that. Okay. So this will be, let's say, let's rename our components now. This could be main parameters. Probably for this 80. If it's not big enough, that should be okay. So that's one. This is the. I don't think we need to group it. We just use this as a sort of like copy and paste, in order to make it easier for us. But we do need to group this one. We can call this. Oh, I forgot. I need to include a scribble. So I'm just going to copy paste that here. Add this to the group. We can call this main setting out outline. Like that. Cool. All right. I think we should be comfortable with the rest, building the columns and stuff like that. Looking at the time, I will stop this video here in order to give you a small break, in order to give myself a small break also. The next step, what we're going to do, we will continue on with this. We can now easily select which floor we want, which is very good for us to build from there on. So we're going to focus on the columns that's on the tip of these. So basically all these big columns here. And hopefully you can move to the side columns, which is why I did not join these elements into one curve yet. We can also do the offset, which is the balcony depth. The balcony's depth here, like this one, where the term says it's balcony. So we're gonna create that. We're gonna make also I think we can even just do an offset here and then call it balcony depth. But we'll do that all in the next part of the tutorial. So I hope you can follow me thus far. If not, do leave a comments in the video and I can help you on from there. So with that said, have a good one and I'll see you in the next one.